Cities are harsh ecosystems, and the animals that survive in them often do so by scavenging our leftovers. Raccoons, for example, have figured out how to thrive on our trash. But occasionally, the dynamic flows the other way. Instead of an animal adapting to our world, we take an animal and actively dismantle its biology to build exactly what we want. The domestic canary was built through exactly that process. This photograph shows the Atlantic canary in its natural habitat. It has subdued, gray-green feathers, designed to blend into the brush. It looks nothing like the bright yellow pet we usually imagine. Over the past 500 years, human breeders took this wild finch and acted as amateur geneticists. They manipulated its lineage generation after generation. They fractured this single wild species down 3 highly specialized evolutionary paths, engineering entirely distinct domains of the bird: its voice, its pigment, and its physical anatomy. The first path of engineering focused on vocal mechanics. Breeders didn't simply select for genetics, they actively created avian singing schools to teach young birds specific melodies. They developed the Hart's roller, a breed engineered to output a continuous rhythm of at least 40 notes per second, dropping its song into a deep musical bass register. To achieve that specific resonance, the Hart's roller performs a bizarre physical feat. It sings its complex melodies with its beak clamped completely shut. Other breeders relied heavily on cultural programming. The Russian canary was trained by its owners to mimic the exact pitch of local flutes, and in the 19th century, some were even taught to sing national anthems. Through a combination of selective breeding and intensive audio training, they turned a wild animal into a programmable biological instrument. The second path of engineering focused entirely on pigment. Starting in the 1600s, breeders systematically stripped away the bird's natural green camouflage until they achieved a uniform, bright yellow, turning the animal into a highly standardized, commodified pet. By the 1920s, however, breeders grew frustrated by the natural limits of the canary's color palette. To get the exact shades they wanted, they decided to cross the species barrier. They took the domestic yellow canary and hybridized it with a completely different South American finch called the red siskin. The resulting genetic mutation produced the red factor canary. This hybridization marks the historical shift where aesthetic desire drove breeders to use cross-species traits, establishing an early form of aggressive genetic engineering. The third and strangest path involved actively sculpting the bird's physical anatomy, drastically manipulating its skeletal structure and feather growth. Breeders created the Gloucester fancy, shrinking the bird to a miniature size and forcing its head feathers to grow into a thick, artificial-looking bowl cut. At the exact opposite end of the spectrum, they developed the Lancashire breed, pushing the bird's genetics to produce a massive, oversized frame. The most extreme anatomical mutation is the Gibber italicus. It was engineered to be completely emaciated and forced to stand on stiff legs at a harsh right angle, mimicking the exact shape of the number 7. These posture canaries demonstrate how human aesthetic obsession can completely override an animal's natural evolutionary morphology and basic survival instincts. For centuries, these extreme biological modifications functioned as aristocratic parlor tricks, but that tampering eventually yielded an unintended, life-saving utility. 500 years of genetic isolation and physical manipulation produced an animal with highly sensitive, warm-blooded biology and a massively accelerated respiratory exchange rate. This image shows how this fragility was utilized. British coal miners realized canaries would show distress from invisible, deadly carbon monoxide gas before it affected humans. These sentinels were so valuable, miners built sealed cages with attached oxygen cylinders to safely resuscitate them after exposure. Today, this same highly manipulated biology is vital in modern laboratories. Researchers use the canary's unique vocal learning pathways to study neurogenesis, the process of how adult brains form and connect new neurons in response to sound. We often categorize the domestic canary as a caged pet, but underneath those yellow feathers is a 500-year living canvas of human ingenuity, a bird that saved thousands of lives underground and continues to map the frontiers of